Using Pythagorean theorem. Uh, Basically, what we have here is you have it where you have 2 points and you want to find the distance between them. So I'm doing this in general. This is for any 2 points. So this point right here, I'm going to call this point x1, y1. Okay, this is any point. This could be any x value, and then this could be any y value. So this is any point, x1, y1. Now this point right here is of course any other point, but I got to distinguish it, so I'm going to call it x2, y2. And now basically what I'm going to do is I'm going to compute the length of this line right here. And the length of that line is going to be the distance between any 2 points, x1, y1, x2, y2. And the way that I do that is that I look at this figure, and I can always do this. I could always draw this resulting triangle like this. So so let's see. Let's go back again. There we go. Okay. I could always draw this resulting triangle like this. I could say this line going down, and then I could draw another one, and I can complete this triangle right here like that. And I can always do that for any 2 points. It doesn't matter the 2 points that I pick, where this is a right angle. Now with this figure, we just have to come to we just gotta like sort of realize certain things. If you look, this point is x2, y2. We should know that then this is x2 down here, right? And then this is y2 up here. Because the ordered pair for that point is x2, y2. And I mean, if you have trouble seeing that, you should see, like, let's say this is 1, let's say this is 5, right? And let's say that this is, I don't know, 2, and then let's say that this is 7, right? You guys should see that this point right here is 1, 2, and that this point over here is 5, 7. Okay? This is the general idea. Like, this is 5, right? If I went up, this would be x2 along x. Now, the key here is using this example. If you look over here, right, what is the length between these 2 points? Or what's the length of this line right here? Or in general, this line down here. The length of this line is 5 minus 1, which is just 4. And that's the length of this segment right here, or this side of the right triangle. And then what's this length? Well, it's going to be the same length as this right here, which is just 7 minus 2. Now that's the particular example. You have to understand this in general. In general, if this is x1, this is some value over here, and this is x2, the length of this side right here is x2 minus x1. And then if you look over here, the length of this side is a similar thing. If this is y1 over here and y2 over here, then this length is y2 minus y1. Now I'm sort of like done with it being in the coordinate plane. I really don't need it anymore, but we have our triangle, which is the relevant factor, because all I need now is this side length again. I'm looking for the distance between these 2 points. That's the length of this side right here. And we have a theorem that involves right triangles that we're going to use. That theorem is Pythagorean theorem. So let's write Pythagorean theorem. And it basically says that for any right triangle, if this length is A, and then this length is B, and then this length is C, you have a relationship among all 3 of these sides, which is A squared plus B squared equals C squared. And with this theorem, we go on and we prove the distance between these 2 points, because now I have a right triangle right here, right? So I'm going to pull out that right triangle. I'm going to pull this triangle out to right here, so we get a better picture of how we're going to apply Pythagorean theorem. And we already know that this length right here is x2 minus x1. I know that this length over here is y2 minus y1. And the basic idea here is I know this side squared, a squared, plus b squared, this side squared, has to give me this side squared. Now, what I call this side is up to you, but what am I looking for when I'm talking about distance? I'm looking for a distance, right? So I want to call this side d. And d is the hypotenuse, c is typically used for the hypotenuse, but it doesn't really matter what we call it. I just want to label it d in this case because I'm looking for a distance. Okay? And again, Pythagorean theorem says that the sum of the legs squared equals the distance, the hypotenuse squared. I apologize. And in this case, the hypotenuse is the distance between these 2 points. Okay? So now what do I have here? Let's see. Let's call this side B or A. It doesn't matter, B or A. If this side is A, and then let's say this side is B, then what do I have? A squared plus B squared equals D squared. That follows from Pythagorean theorem. A squared plus B squared equals D squared. This side length squared plus this side length squared equals this side length squared. I just wrote A just to illustrate and B just to illustrate, because what that means is that this whole thing squared, x2 minus x1 squared plus y2 minus y1 squared is going to equal the distance squared. Now I don't want the distance squared, I want just the distance. So what I do here is I take the square root of both sides of this equation. And I get the square root of d squared is just d, and I get the square root of x2 minus x1 squared plus y2 minus y1 squared as the distance, as d, this length d right here. And that's the same thing. I pulled out this triangle is the same as this one, so this length right here is given by this formula. And again, these were any 2 points, so this formula will work for finding the distance between any 2 points.